Alright, so another problem we're going to do with kinematics says that a plane has takeoff speed 90 meters per second and requires 1,200 meters to reach that speed. What it's asking us to do is determine the acceleration of the plane and the time it takes for the plane to reach this speed. So I'm going to erase this so that we can work this out. So I'm going to go ahead and write our variables so we don't forget. So we have takeoff speed of 90 meters per second, and it requires 1,200 meters, so we can say our delta x is 1,200 meters. And we want to find A, and we want to find T. Alright. So the first thing we want to do is look at our kinematic equations. So we want to find A and we want to find T. We're given the final velocity, and I'll rewrite what I wrote up there. We're given our final velocity to be 90 meters per second. We're given our delta x to be 1,200 meters. We want to find A, so the variables in question here are A and T. Okay. So there are a few assumptions that we can make involving this problem in particular. We can go ahead and assume that the plane is starting from rest. We can assume that it leaves the gate, and before it starts its acceleration to take off, we can assume that it started from rest. So what I'm going to write here is our V naught, or V initial, is equal to 0 meters per second. We can also say that it starts at 0 meters. We can define its starting position to be 0 meters. Okay, so it ultimately travels 1,200 meters from the starting position of 0. Okay, so we want to find A and we want to find T. So looking at these equations, what can I use to find A? So I'm looking for an equation that involves A, that also involves variables that I already know the value of. So in these four equations, we have 3 involving A. But one of them involving A, we have x naught, v naught times t, plus 1/2 at squared. Well, we don't want to use that because there's 2 unknowns in this equation. There's A and there's T. We don't know either of those yet. So for this one, we know velocity final, we know velocity initial, and we have A times T here. There's 2 unknowns. We can't use that equation. Okay? So here on the last equation, we have final velocity squared plus initial velocity squared equals 2A delta x. We know final velocity, we know initial velocity, we don't know acceleration, we're trying to find it, but we do know delta x, which is up here. So we only have one unknown, one equation. We can solve for A using this final equation right here. So I'm going to rewrite that equation. So Vf squared equals V naught squared plus 2A delta x. Okay. So what I'm going to do now is go ahead and plug in the values that I'm given. So here, velocity final, which they gave us in the problem, was 90 meters per second. And we're squaring that using this equation. Equals the initial velocity squared, which we determined to be 0 because it's starting from rest. So 0 meters per second squared plus 2 times A. We don't know A yet, so we don't really have a value to plug in. And our delta x up here was 1,200 meters. That's how long the runway is. So we have 1,200 meters there. So what we can do now is we can go ahead and get rid of this. that just goes to 0. All right, so when we square this final velocity, we're going to get 18,000 meters squared over seconds squared equals, this went away, so all we have left is 2a times 1,200 meters. So I'm going to go ahead and multiply 2 and 1,200 to get 2,400 a, and this technically has meters here. So we have 18,000 meters squared over seconds squared equals 2,400 meters times a. Okay, so we can divide by 2,400 meters on both sides, so that the 2,400 meters cancels here to 1, and divide over here by 2,400 meters, which means that the meters in the denominator cancel with one of the meters in the numerator, so that we're left with this equals 7.5 meters. We still have 1 meters left over seconds squared, and we still have this a term left over. So the acceleration of the plane on this takeoff is 7.5 meters per second squared. A good way to check that at least you're on the right path with what you're trying to find. Meters per second squared is the right units for a. So whenever you're trying to find acceleration, make sure you're looking for meters per second squared. When we find time, we're going to try to look for just seconds itself. So the next part of the question is, so let's go ahead and write that a was equal to 7.5 meters per second squared. Okay, so now we need to find the amount of time it takes for the plane to reach this speed. So again, whenever you're trying to find something, just look at your equations, see if you have an equation involving your unknown, that you also have variables that are known. So when I'm looking at this one, I see final position, initial position, velocity times time. That's not really going to help us do anything because our initial velocity was 0. So we're going to get this whole thing canceled out. That doesn't help us at all. This one, we just found a. We have this and we have this. So we can use this equation to find time because this is a known, this is a known. Now we know a, so we only have one unknown with one equation. So I'm going to write that same equation. The final velocity equals initial velocity plus a times t. Okay. So plugging in what we know that initial velocity just goes to 0. We know that the final velocity is 90 meters per second. And we just found a, so we can say 7.5 meters per second squared times t. Okay? So all we need to do to solve for t is divide by 7.5 meters per second squared on both sides, making this 1 over 7.5 meters per second squared. And when we divide 90 meters per second by 7.5 meters per second squared, we end up with just 12 seconds, which equals our time here. And we know that we're finding the right variable here because meters over seconds squared, your meters cancel out, and one of the seconds up here cancels out, and you're left with 1 second left over, which goes right there. So you're left with 12 seconds, which is the amount of time that the plane takes to take off from the runway.